Welcome back to PA Academy. So right here is the second example we are going to be looking at under call of a vector function. So the question says, determine call f at points 2, 0, 3, given that, now this is the function, z exponential 2xy I plus 2xz cos y, and then the coordinate is j, and then x plus 2yk. So before we get started, don't let the cos, the exponential, and how long the function is to scare you. So once we simplify it, you see that it's not really something that you should worry about that much. So before we get into the solution proper, if you are yet to subscribe or you are new to this channel, please kindly take out time to click on that subscribe button. You'll find it somewhere here at the lower right of your screen. You see an option there to subscribe, or a red icon with subscribe written on it. Please kindly take out time now to click on that subscribe button. Alright, so thank you very much if you have just done that, and let me know in the comment section below if you just subscribed. Alright, so let's look at this call f. So call f, since you are dealing with call, so you are asked to determine call f, and call f is as the mathematical representation of this. Exactly. So since it's called, so let's draw our matrix. So we are going to be having our I, j, and then k. So that's going to be on the first row. On the second row, we are going to be having the partial differential over that of x, partial differential over partial differential of y, and then for that of z. Are we good? So then on the third row, we are going to be having each of these functions. So for that of I, which is this, so that will be z exponential 2xy, and then for that of j is this, so that would be 2xz cos y, and then for k is simply x plus 2y. Alright, so now let's solve it now. So like I said in the previous part, you are just going to solve it the same way you used to solve for determinants of a matrix. Okay, so we are going to be having our I. So let me just open this square bracket. So the next thing we are going to do is multiply this and then subtract this from it. Alright, so let's do that. So we are going to be having partial differential of y, partial differential of y, multiplied by x plus 2y minus partial differential of z in brackets 2x z cos y. So that's for the first square bracket, and then for the second one we're going to be having minus j. So don't forget, the same way you solve for your determinants. So for the j, so since it's j now, we are going to ignore this particular column. So if you ignore it, we are going to be multiplying this with this, and then we'll subtract the product of this and this from the initial multiplication. So let's do that. So partial differential over that of y, so that's this multiplied by this, x plus 2y minus partial differential of the partial of the z, so that's this multiplied by this, into bracket z exponential 2xy. Okay, so that is for j. Now let's go to k. So for k, I'm going to ignore this column and multiply this with this. No, I mean we're going to multiply this and then we'll subtract the product of this from the initial one. So that will be partial differential over that of y, z exponential 2xy minus over x so this will be d over dx. multiply by 2x z cos y minus e over dy of z exponential 2xy. So now let's go ahead and differentiate this. Again, this is going to be a very simple process. So don't let the exponential and cos to make it look like it's a very difficult question. So now let's start with this. So our I. So if you have to look for, if you have to differentiate this now, this is the partial differentiation of this. Exactly. So there is no x here. I mean, there is no y here because we are differentiating with respect to y. There is no y here, so this is just 0. So for this now, this is 2y. If you should differentiate 2y, you are going to get 2. So that will be 2. So that means we are done with this minus. So partial differentiation for z. So now let's look at this function. We are having z here. This is the only z we are having. And if you should differentiate that z, that's 1. So every other thing will remain. So that means we are going to be having 2x cos y. And that is it for I. So let's go to j minus j, and then let's open our square brackets. So if you should differentiate this, we are differentiating with respect to y. So since there is no y here, this is just 0, and this is the only place we are having y. Okay, so just in case you've seen it earlier, there seems to be a mistake somewhere here. So now for this j, when we are dealing with minus j, we are considering this and this. So this should be, let me quickly correct that, partial differential of x, and y this. So this and this will multiply, and then will multiply, and then we'll subtract the product of this and this. So this should be y. Exactly. So that's the modification there. So let's continue. So if you have to differentiate this now, since it is x, so that means this will be 1 and this will be 0. So with that, we're going to be having 1 minus. So let's continue. Even that y is z. So not this. It's actually this, because we are considering the j part. So if you are considering the j part, we just ignore everything here. So this is z. Sorry for those mistakes. Right, so I had to just correct it on screen because I won't have enough time to start editing it behind the scene. All right, so now let's continue. So these are just some of the mistakes that you can just come across when you are doing this kind of work. So you just need to be careful. Exactly. All right, so now let's differentiate what we are having here. This is z here, so that will just give us 1, and the other things will remain. So we are going to be having exponential 2xy. So let's close that. So let's look at k. So plus k. So let's look at, if you should differentiate this now, d over dy with respect to x here. So this is the only x we are having, and that will become 1. So we'll be left with 2z cos y. Then let me put the minus here, minus. So if you should differentiate what we are having here, all right, so if you should differentiate this is where we are having the y. So that will be minus 2x, and then every other thing there will come back. That will be z exponential 2xy. So this has to do with differentiation of exponential function. All right. So at this point now, let's recall that we are given that the points at points 2, 0, and 3. So at points 2, 0, and 3, so that means our x, is equals to 2, y is equals to 0, and z is equals to 3. All right, so that means our enabler cross product of f will be equals to I. So we already have this to be 2 minus. All right, so let's do this. So that will be 2 times, our x is 2, times cos y. So that's cos 0. And if you type cos 0 in your calculator, that will give you 1. Exactly. So cos 0 is 1. So that's just like multiply by 1. So this will give us 4. So let's go to this other part. So that will be minus j. That will be 1 minus. So exponential 2xy. So 2xy is the same thing as 2 times our x is giving us 2 times our y is 0. So everything here is 0. So exponential 0, if you put in the value of exponential 0 is 1. So here we are having 1 minus 1. Very good. So then plus k. So let's do the for k. So for k we are having 2z cos y. So that's 2 times our z is 3 times cos y. That will be cos 0. I think we've checked it earlier. Cos 0 is giving us 1. So that will be times 1. So we're having 2 times 3 times 1, that's 6. Then minus, let's come over here. So we are having 2xz exponential. So let's take it one after the other. So that's 2 times, our x is 2 times z is 3. Then times exponential 2xz, that's 2 times our x is 2xy times 2 times our y is 0. So we're having exponential 0. So again, the value of exponential 0 like we did earlier was 1. So that means all the exponential here is just 1. So that will be 2 times 2, 4, 4 times 3, 12. Then minus 12. Okay? So that's 2 minus 4, that will give us minus 2, and then our I. So 1 minus 1 is 0, so that means this is just out of it. Then 6 minus 12, that's minus 6, multiplied by k, that will be minus 6k. And this here is the answer to the question on the example 2. Okay, so that is it, guys. I hope the explanation is clear. I hope you got the concept. So that is it. We still have 2 more examples we're going to be looking at under call, and every other thing we are going to be still talking about under call, divergence, and gradient. All right. So thank you very much, and I'll see you all in the next one.